Hi, my name is Mariko. I have a hashtag for this talk, which is about perf. And only because I tweeted this on Twitter, and then Sam Sakon came back to me like, that's mine. And he was like, can we do over it? And I don't want to die, so please make it happen to me. Please help me make this mine and not Sam's, because otherwise Sam's going to take it. So, performance. Why am I interested in it? So almost to this day, a year ago, I was just wrapping up my gig as a JavaScript engineer who does JavaScript stuff and then heading out to do a job at web developer relations at Google. So I was writing web application, but I was in enterprise web application, and it was quite a lot of JavaScript. Interesting engineering problem to solve. But I was never in a situation where speed was a big issue for business. Like, just to say that, like, if our site is kind of slow, it didn't really matter because it was enterprise application and it was a critical part of the users, and like user had to use those applications. There was no way they were abandoning it. So I never really considered myself for like. Even though I wrote front-end code, I was like, I can't really like very well front-end engineer because, you know, if you go to web developer relations at Google, the colleagues becomes like, you know, the person who tweets like, you know, colorful chart all the time, or the person who like they call the screen of whatever the dev tools that they're doing and like, you know, throw an acronym at you, or quite literally the person who wrote a browser networking, high performance browser networking. So I was like very intimidated when I joined. And I was like, I don't know anything about performance, let me investigate. So, warning, if you are that kind of engineers who cares about performance and cares about milliseconds of how fast the user get to it, this might be the redundant information. But hopefully there will be interesting angle because I have a lot of drawings. So hopefully this is good for everybody. So speed, right? When we say speed and internet is slow or the web is slow or like, you know, the website is slow, many times we are talking about speed of the actual internet. What that means is that you have a server and you have a client, and then the data travels through the pipe of internet, and then that pipe may be wider or narrower depending on your broadband network. And then that pipe might be filled or not filled. And the size and the flow of the internet, what's happening in the pipe, determines the speed of the internet. Today, we're not talking about that because that's that's out of front-end engineer's hand. We're talking about speed in web application. So what does that mean? Well, first, we have some kind of speed component in the server, like, you know, how fast can you respond? How fast is your SQL query? Those kind of things. So, you know, response time, query optimization, putting on CDN, those are the speed that happens on the server side. And then another one, the second one, is what happens when data travel through that pipe from server to client. So those are like, you know, what kind of request protocol you use and how you deliver the asset and how are you gonna split the code. And then the third one is what happens inside of browser once the data hits the browser. So those are like, how do you render things? How do you handle event? How do you optimize the code? So today, I am going to focus number 2 and 3 and just skip over all the server-side stuff because there's so many stuff on the speed. And when we talk about those two stuff, there's a numbers that people keep referencing. Numbers are this power of 10. And this comes from a usability engineering published in 1993, but then the book itself referenced the data coming from 1968. 100 milliseconds feels instant. So when something responds in 100 milliseconds, that means, oh, this is instant. And this isn't only for web application. You can be designing, I don't know, train ticketing system, you know, when at the train ticket booth, when somebody push or do something, if something happens in 100 milliseconds, that feels instant. And then the 1,000 millisecond, 1 second, that's the focused attention span of a user. So that's only time that you have 100% attention from this user. And then beyond that, you have 10 seconds to have a partial attention span. So this might be, if this was you buying, I don't know, the train ticket system, and then the machine is not responding to you, you might check your phone, but you still care about what's happening on the machine. And then beyond 10 seconds, you completely lose it. You just give up. So those are the science of number coming from 68, published in 83. And when you read about performance, this number gets referenced a lot, and seems like, from my research, only one place from 68 is the place that comes from. Of course, when we talk about web application performance, we talk a lot about 16 milliseconds, 60 frames per second, where animations are smooth, and this doesn't count into that. So, loading. Let's talk about what happens in that number 2 and number 3 seconds, right? 3 part, right? So recap, loading. You need to load a data from server to client and do something on the client within 10 seconds and 100 seconds, 10,000 and 1,000 milliseconds span of things. And inside of a loading, there's 2 parts to it. So the first part is getting data to the client. So what happens in between server and user's computer, right? And this gets a little confusing at the moment because we as an industry is in transition of protocols. So let's see it. So if you are using HTTP 1.x, 1.1 most likely, the way it works is that the browser receives data and then look at it and HTML, oh, okay, I need these image and script and CSS. So then client and server does this response and reply actions of hey, I need this thing. And then browser says, here's the thing. And then, you get the status codes and everything. The modern browser open up to 6 of those response and back connections per domain. So, which means if you have, 100 images to load, then only 6 can happen at a time. And when somebody requests it, that connection has to wait for the response to come back. Otherwise, they can't move to the next one. That means there's a performance optimization techniques like image split, where instead of loading tiny 100 fonts, icons, and making 100 requests, let's just make it a 1, and then just move by CSS to do it, save those, or domain sharding. So you can only open 6 connections per domain, so have different domain, or JS concatenation. Instead of having 100 module flows on the browser, let's concatenate into 1 or 2, and then save that loading part of the budget. However, if you are using HTTP 2, which is newer version of a protocol, then this basis gets broken, completely different. So HTTP 2 only opens TCP/IP connection between client and one per domain. So that means you only have one tube between you and the domain or the server, and then inside of that flows a chunk of data. So it's doing multiplexing. You request, I need this thing, and then I need that thing, and I need this thing. And then while server gets your request, server also replies back you, here's a little bit of A, here's a little bit of O, here's a little bit of yellow, 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 here's a little bit of blue coming in, here's a little yellow again, or green, green. So it's data is coming in stream, and data is coming in multiplexing. And this also gives us ability to do something like push. So let's say you are serving HTML. If you wrote a server code and if you're serving HTML, you damn sure know what kind of font that this site is going to use. So sometimes you can use oh, you requested me HTML. I for sure know that in order to render this HTML, you need this font. So you can kind of send the data before the request comes in, and that's called push. However, this thing requires HTTPS. So if you were not, so HTTP2 spec itself does not say you have to use HTTPS, but no other browser implements HTTP2 without HTTPS. Another way you can get the data faster to user is something like Service Worker, where the data that previously requested are cached in user's computer. So when user makes a request, it asks for cache, like, is this data still exist in your cache? Then if it is, you don't even need make a network call, and then you just get the data from the cache. So that makes it faster. Again, Service Worker requires HTTPS. So here are the 2 minutes of why HTTPS is required on those things. And it did not make sense to me until I learned what this thing is. And warning, warning, join. So HTTP, the not secure version, the regular version, is kind of like sending postcards. Like you sign, a nice letter to Ellie and then send it from New York to London. Like Postman can read my postcard, no problem. It's just this data is flowing in between, flat, right? Which means that like somebody who is not even trying to do bad thing can read those data. So this is called man-in-the-middle attack, where somebody is eavesdropping and then maybe eavesdropping and collecting the data or modifying the data to do a bad thing on your computer. This is not something you want to do when server have a power to push some data without you requesting, or server have a power to send the code that lives on your cache. So this is why HTTPS is required for many of the modern APIs, I guess, and then the powerful APIs. So what's the difference when you move to HTTPS? HTTPS, it's weird to explain, but so the people who can still see the data is flowing in between me and Ellie, right? They can see I sent something to her or she sent something to me. However, me and Ellie are the only one who can read those data. No other people can see what's inside of the data that's flowing. And on top of that, I get this certificate where this is definitely from me or this is definitely from her. So I have a peace of mind, that assurance that like, okay, this data, it's not being read by somebody else and not being modified by somebody else, which is nice if you think about those powerful APIs that require HTTPS. Like you have a peace of mind of like, okay, this is actually kind of important and security information that I would like to keep it to myself, or somebody who I ask for it, and not anybody else. So that was 2 minutes on HTTPS. And the previous one was how to send the data. Another one is getting data onto screen. Like what happens once you have all of the code coming into your browser? How do we draw a pixel on the screen, right? So imagine you are going to make this basic website that just shows hello world and big bold text in blue, right? First, as with anything, the browser requests HTML, gets HTML back, and then say, oh, okay, HTML tag, okay, you have a header. Okay, I found CSS, so let's go get CSS. So browser go get CSS, and then go read like, okay, parses through, build a CSS OM, and then okay, done. I know what the CSS is needed for this page, so move on to next line on the HTML. And then they were like, oh, I found JavaScript. I'm gonna get JavaScript again. So you download the JavaScript, go through it, and then see something like, oh, here's a set timeout. Okay, I'm gonna wait for 10 seconds until it's done. I'm not going back to HTML. And then once that's done, then it goes back to HTML again, see the hello world, and then so what you see on the front end is like, okay, HTML requested, that 10 seconds thing is happening, browser is parsing through data, and so many seconds later, you get hello world. But wouldn't it be better if you have something like, okay, request goes in, immediately hello comes back, so that you have that visible feedback of like something is happening, and then the world comes back after. So that's the part we were talking about, the response, the load time, where when somebody says like, you have to load something into user's screen so that you don't lose users, backed by these science, means that it doesn't have to be loading entire app data to the client within a second. But you want to think about your usability and your UI so that some kind of visual indication that your app is doing something goes to the user, so that user doesn't completely give up on your app. In order to do so, there's like a few things that I throw into the slide, and there's like much more extensive blog posts by many of my colleagues online, so I would highly recommend Googling. One thing you can do is putting async attributes on your script tag, which means it's telling browser like, hey, this JavaScript, it's not really critical to block the rendering, but I will need it later, so can you just download it when you have a time, please, so asynchronously. Another one is link rel preload. So this one is basically hinting to the browser, saying like, going through the header, and then in the header say, hey, I will need this thing soon, so can you please download it now? And then once browser goes down and then finds the main JS, then it loads the JavaScript data into there. So those are the two things. And then like the link rel part have a few different families, like prefetch and all of it. And there's like a many nuance to it. So if you're curious, I highly recommend Googling. Another part is rendering. So when we talk about rendering, we talk a lot about animation. How smooth can we have 60 frames per second or not? I'm not going to talk about that today. There's so many CSS optimizations and how you should do animations article. I want to talk about response because it directly connects to the science number that we talked about, which is 100 milliseconds, where feels instant. So this is still what's happening inside of the browser after you load the code. You have some code like this, probably. You have some kind of button that says, click me. And then when user clicks on it, inside of the browser, what's happening is that you have some kind of event handler in orange, and then that event handler goes through your application logics, checks the state, what's happening in there, and then you probably call like render function to do something, right? Whether you send the user to some other pages, or you send a confirmation, anything. Well, it doesn't have to be render, maybe like move the page, but you do something, right? So this thing needs to happen within 100 milliseconds according to the science of user interaction in order for user to feel instant. In fact, this only have a 50 milliseconds budget. You don't have a full-on 100 milliseconds because user clicks on something while you are doing some other JavaScript, like long JavaScript. So think about this one block as a 50 milliseconds. What if you are running, I don't know, some kind of data processing or something, and you are running 200 milliseconds job. User clicks on it in the beginning of 200 milliseconds job, then the user have to wait because this green block where the click handler executes, it has to wait until already running jobs are done, and then your click handler gets executed. So the thinking is that if all of the JavaScript job you do are within 50 milliseconds, that means even if user clicks on it on the beginning of the job that's totally unrelated to the click handler, you can still queue up the click handler JavaScript and end up under 100 milliseconds, which means you are assuring that the users are getting immediate feedback, or feels like they are getting immediate feedback. So in order to do this, if you have a long task, when you look at a trace on the dev tools, you can think about how you can divide each tasks and what can be delayed and what can be executed, what needs to be executed immediately. Browser have a kind of like a handy method for request idle callback, where it's called when the queue for the JavaScript is like empty, and they're like, I'm ready to take on new job, and this one gets called, and then another one is request animation frame, where every animation frame, it gets called. Every tick, you get it. So you have that control to scale your task based on how you structure your code. And this is, I only have this very simple slide because it's highly dependent on what kind of application you're making and what kind of logic that you're putting into your application. And it's kind of hard to show generalized, like, this is the best practice code. So really depend on what you do. But then you might be saying, like, what about JavaScript, right? Making fast JavaScript code is a thing. Like, you don't want to write for each. You are supposed to write like for loop by hand every time because that's faster. I definitely got this maybe like 3 years ago at a job interview where like we were talking about like JavaScript, and I was interviewing for JavaScript developer, and they were like checking like how well you know JavaScript, and I was like, oh yeah, I wouldn't use for each. It's slow. I would just handwrite it myself all the time. But that's not the case, well, at least for the Chrome. V8 team, which is a JavaScript engine for Chrome, is putting a lot of effort into making idiomatic JavaScript faster, if not just the same amount. So you should write ES6. Like, it is true. It used to be very slow to use ES6 classes on the browser, or it used to be slow to do for each. But if it's slow now, they have a focus on making idiomatic JavaScript as fast as the old way of doing it. So if you find some kind of bottleneck, you should definitely tweet at them or tell me, and that's on their mind. And you should use it. You should move on to writing, the modern JavaScript, and you shouldn't be stuck on an old one or the hard to parse code just because the browser engines happened to be faster a few years ago. So there's many, many, many more things about performance. If you have something that is confusing, or it doesn't have to be rendering related, if you have any questions, I am actually the person behind Chromium Dev's Twitter. I am the person who sends tweets every Friday with like, here's what we've been doing, and I occasionally share things that happen with the community. I'd love to know what you're building and what you have a question of so that I can better prepare for those things. And thank you very much for your attention.